Hi everyone, today let's solve the problem Ardent Flames. So this was basically asked in Codeforces round 988 div 3, right? So the last two questions F and G I think. So if it was asked in basically Codeforces round 198 sorry 988 this one div 3, right? Ardent Flames. Ardent Flames basically means the flames that are intensely hot, the flames that are bright basically. The name suggests that flames that are intensely hot or bright. So like that you can consider, right? So what the question states here, you can just go through the question is very easy to understand basically, to be frank. So I'll just summarize the question so that it will be easier for us to understand, right? So what the question states here, we have n enemies, right? So just give me a second, 1 second. So we have n enemies, right? So we have n enemies that is placed at sorted positions. So that is placed at sorted positions. We don't have to worry about the sorting now. That is clear, right? So we have n enemies placed at sorted positions with individual health. With individual health. This part is very important. Just keep this in mind. We have n enemies placed at the sorted positions with individual health. We can place the character Silonen, we can place the character named Zilonen. So just take this name. Consider this name for now. They have given in the question. So we can place the character Zilonen at any integer point p. So we can place this guy character Zilonen at any integer point p, right? At any integer point p and perform a ground stomp that deals m minus uh, m minus absolute value of x minus p, m minus absolute value of x minus p. So we can ground stop means something that is heavy, right? Something that is heavy, stopping, or this one stepping in or stomping on something, we say, right? Something that is uh, we are heavily stepping on, basically you can consider in that way. So we can place the character Zilonen at any integer point p and perform a ground stomp that deals with m minus absolute value of x minus p. So here when I say value, so this is basically m minus absolute value is nothing but, so we have to get the value at any cost, we have to get the value positive value. I mean at any cost we have to get the positive value, the value shouldn't be negative. So we'll be making use of absolute value here, in this case x minus p, right? So m minus absolute of x minus p here. So damage to enemies within the distance m minus 1. So within the distance m minus 1 they have given here. So again I'll read out this one loud, just listen to these sentences very carefully, right? So we have n enemies placed at sorted positions. So we don't have to worry about the sorting. So we have n enemies placed at sorted positions with individual health. We at individual with individual health. So we can place the character Zilonen. We can, this is nothing but the character name. We can place the character Zilonen at any integer point p, at any integer point p and perform a ground stomp that deals deals m minus absolute value of x minus p, m minus absolute value of x minus p damage to the enemies within the distance m minus 1, right? Simple to understand. So we can perform this attack multiple times. So we can perform this attack multiple times but always from the same position p. Just keep this in mind, this is very important. We can perform this attack multiple times, we can, right? So any number of times, it doesn't matter, we can perform this attack multiple times but always from the same position p. See here, so here this p I'm speaking of. We can place the character Zilonen at any integer point p. Once we have placed the Zilonen at any integer point p, we can perform the attack multiple times but always from the position p that we have placed the Zilonen, right? So that we need to keep in mind. So what we need to find here then, right? Question is somewhat scattered, right? So we don't know still what to find basically. So here in this case, we have to find the number of attacks that is required to defeat at least k enemies. So we need to find, so number of attacks, right? Number of attacks that is performed, number of attacks performed, or number of attacks that is required to defeat at least k enemies, or we have to return -1 if it is impossible. So -1 if it is impossible, this is one of the edge case, and we have to find the number of attacks that is required to defeat at least k enemies. Number of attacks that is required, minimum number of attacks basically, right? We have to find the minimum number of attacks that is required to defeat at least k enemies. Minimum number of attacks that is required to defeat k enemies, or we need to return -1 if it is impossible. We need to return -1 if it is impossible, right? So I hope this part is completely clear. I hope the question part is completely clear till whatever we saw, right? So let's come to the input part. Let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. Before discussing the approach, let's come to the input part and let's discuss certain things, right? So here, one thing I need to tell you here is, just give me a second. We have m, x and p. So x and p, we saw that one, right? M, x and p, and we have h and k as well. So here when I come, suppose we consider we have 6 inputs. 6 represents that we have 6 inputs, right? So for the 6 inputs, we need to have 6 outputs here, this one. So here in this case, first input is this. When I hover over here, this first input, this is showing 5, 5, 3 we have, right? N is nothing but 5 here. Uh, M is nothing but 5. N and M and N both are 5 here. K is nothing but 3. And this H is given by this one. Numbers we have here is nothing but H. 777, 5 times 7 basically, right? So here 1 2 3 4 5 is nothing but the x, absolute value of x minus p, what we have discussed in the question. M minus absolute value of x minus p, if you remember, right? M minus x minus p, absolute value of x minus p, if you remember, right? So here x is nothing but 1 2 3 4 5. So for this input we need to get the output 2. Same thing goes for the input 2 3 4 5 and 6, right? So for the approach, we'll be considering this example. Let's see how can we get the output 2. Let's see how can we get the output 2, and you can just try it out in the same way for the other inputs. I insist you to try it out for the other inputs after discussing the approach, so that you'll understand the question clearly and how to solve this one, right? So we are not giving any contest to rush basically. To solve the problem in a hurry, we are not giving any contest, neither we are giving any interview currently, right? So take your time. Just I insist you to try out with the different inputs, right? So now let's discuss the approach first, followed by the complexities, and then let's write the code. Initially, as usual, let's discuss the approach first. So let's consider the first input or the first example that they have given in the list of examples, right? So let's consider the first example. So n, we have been given 5, and m is 5, k equals 3. We have discussed this one. We have already seen the first input, right? Just before considering this one, just before discussing the approach part, we discussed the same thing, right? So h, we have been given 5 sevens, and x, we have been given 1 2 3 4 5, and the output that we need to get here is 2. So the output that we need to get here is nothing but 2. So here, first thing that we need to keep in mind here is we will be going with the binary search, right? So we will be going with the binary search. So just keep this in mind. We'll be going with a binary search. So let's go with a step-by-step explanation here. Let's move on with the step-by-step explanation. First thing is we will be performing binary search. So we will binary search on the number of attacks, nothing but h. The number of attacks is represented by h, and we'll perform binary search on number of attacks h between 1 to 10 to the power of 9. 1 to 10 to the power of 9, nothing but 1e9 here, right? 1 to between 1 to 10 to the power of 9. We'll binary search on the number of attacks. Again, I'm telling we are not going with the indices or nothing. So we are performing mainly binary search on the number of attacks h between 1 to 10 to the power of 9. So let's do one thing. Let's manually simulate this one, right? How this works for the particular case means we are considering this first example, this part, right? So the output that we need to get here is 2. Let's see. Let's simulate the same thing, right? Let's try to simulate the same thing. First, let's go with 2 attacks, right? So we let's just go with a guess that can we kill 3 enemies in 2 attacks. So number of h is nothing but the attacks, right? H is nothing but the attacks. We're just taking a guess. Let's go with the guess. Can we kill 3 enemies in 2 attacks? So let's calculate the same for each enemy. So enemy here, enemy can be killed in H attacks if we have these things, if we go with these conditions basically. So this is nothing but math.seal, seal of H of I bar H of I divided by H if it is less than or equal to M. Seal of H of I is nothing but this one, H part is nothing but this one, right? H of I. Let's consider 7 here. Let's consider 7 here. H of I is nothing but the 7 and H is nothing but number of attacks. So here we are considering H equals 2. This one I'm speaking. H equals 2. Right? 7 by 2 will go. So we are performing the seal operation. We'll get this one the whole number, right? So we'll be getting 4 instead of 3.5. We'll get the value 4 here. So we will check whether 4 is less than or equal to 5. We'll check whether 4 is less than or equal to 5. Yes, 4 is less than or equal to 5. And yes, so we can kill all. So means we can kill the 3 enemies and 2 attacks, right? So 3 enemies, we can kill the 3 enemies and 2 attacks. So we can kill all when H equals 2. We are just going with a guess, right? Yes, we can kill 3 enemies or we can kill all here in within the 2 attacks, right? So this is fine. So for each enemy, we will compute the needed hits as well as spare, right? For the needed hits, we'll go with seal. We already know this one, right? 7 by 2 seal of math.seal of 7 by 2, nothing but 3.5. The whole number we will get 4, nearest number basically, right? Spare m minus needed hits. M minus needed hits. M here is 5. M here is 5, right? Here needed hits is 4 and M is 5. 5 minus 4 is nothing but the output that we got here is 4. The 1, sorry, the output that we got here is 1. So interval of valid p values that can kill this enemy is x of I minus pair, comma x of I plus pair, x of I minus pair and x of I plus spare. So this is the formula that we'll be going with. This is the formula that we'll be going with, x of I minus pair, comma x of I plus pair. So let's list each enemy's valid interval of p. So let's this is just for the sake of understanding purpose. You can just have a look into it, right? You'll understand this one clearly. We are just going with the intuitive approach here, right? So I'm just showing the calculation part. If you just want to know how the code is written, you can just hop into the coding part. So if you want to clearly know the calculation part and how this is solved, basically this is purely based on the intuition, right? So I can just look into it, right? So here we have 5 enemies basically, right? So it starts from 0, 1, 2, 3, 4, and x of I starts from 1, 2, 3, nothing but the length here, 1, 2, 3, 4, 5 basically. So interval to kill when spare equals 1, spare 1 we have got here, this one from here, spare m minus needed hits, nothing but m here is we have the value for m we have got is 5 and needed hits was 4 and the enemy that we need to spare is 1, right? So here in this case for 1 the interval is 0 comma 2, for 2 the interval is 1 comma 3, and for 3 the interval is 2 comma 4, for 4 the interval is 3 comma 5, and for 4 this one, for the interval is this one, 5 comma 6. Sorry, for 5 either you can consider x of I or you can consider for enemy, right? So I hope this part is completely clear, right? So this is nothing but the we are listing the each enemy's valid interval of p. We are just listing each enemy's valid interval of p. M equals 5, just remember this. So we went with 0, 1, 2, 3, 4. This is nothing but the x of I, 1, 2, 3, 4, 5, and this is interval. This is interval 0 comma 2, 1 comma 3, 2 comma 4, 3 comma 5, and 4 comma 6. So these are the intervals. Pair 1 we have got, right? So interval to kill. So this is fine. So next what we'll do, let's check whether we can find p that is inside at least 3 of the intervals, nothing but 0 comma 2, 1 comma 3, 2 comma 4. First one, when p equals 2, when p equals 2, right? So when p equals 2, whether this is inside 0 comma 2, 1 comma 3, and 2 comma 4. So here yes, 3 is, right? So here again 3 is, right? So just give me a second here. Basically what we are doing, we are checking, so we are just going with the intuitive part that whether the question may arise, right? So here can we find the point p that is inside at least 3 of these intervals, means 0 comma 2, 1 comma 3, 2 comma 4, first one, this one I'm speaking of, and the second one goes with 1 comma 3, 2 comma 4, 3 comma 5, and third one goes with 2 comma 4, 3 comma 5, 4 comma 6. When p equals 2, yes, p equals 2 is inside this one, 0 comma 2, 1 comma 3, 2 comma 4. When p is 2 here, you can see here, right? um, this one, what do we call, where did this go? Just give me a second here. Not this one, man. Yeah, x of I minus pi x of I. Yeah, this is fine. Just give me a second here. Sorry. Yeah, here p equals 2 is inside 0 comma 2 and 1 comma 3 and 2 comma 4. So yeah, here we have got the three intervals. We have got the three intervals, and yes, this is possible. So this is possible. Yes, p is inside at least three of the intervals, right? At least three of the intervals, right? So this is possible. Next, let's go with the value p equals 3. We have went with the p equals 2. Yes, p of 3 is inside 1 comma 3, 2 comma 4 and 3 comma 5. Yes, this uh, p is inside at least three of the intervals, right? Then we'll go with p comma 4. Yes, p equals 4 is also inside, is inside within 2 comma 4, 3 comma 5 and 4 comma 6 intervals. Yes, this is inside at least three of the intervals. So this is also correct, right? So the answer that we considered, h equals 2, the number of attacks equals 2. We just took a guess that h equals 2 as it is the lowest number, lowest numbers, right? So either we can start with 1 and then go with the 2, or we can just go with the 2, right? So we went with the 2 because I wanted to show you the one that actually works first, then the one that actually fails, right? So here, yes, you can just try for h equals 1 when we can perform one attack, right? So it will directly fail. So I just took the this one, second one first, h equals 2 first, right? So here answer h equals 2 is mainly possible. Answer h equals 2 is mainly possible for this, right? So now let's check when h equals 1. When h equals 1, so here needed hits equals 7. Again here, this one I'm speaking of, needed hits equals 7, right? Needed hits equals 7, and just give me a second here. Yeah, needed hits is 7 here, and 7 greater than m. Here m equals 5. The value of m for h equals to, also we have considered 5 itself, right? So they have given value of m equals 5 and m equals 5, and 7 is greater than 5. 7 should be, I mean, the value here should be less than or equal to 5, or less than or equal to m, basically, right? We have discussed this one somewhere, if you know, right? It has to be less than or equal to 5. So here 7 is quite obviously greater than m, nothing but the value 5. So none of the enemies here can be killed. None of the enemies here can be killed. So this fails miserably. So 1 is too small. We cannot consider h equals 1, right? So we can consider h equals 2. So final binary search thing, final binary search, this one, when we apply binary search, so the output that we got here is 2. So final binary search, the output that we got is 2. 1 fails because 7 is greater than m, or 7 is greater than m. Actually, the value should be less than or equal to m. 7 is greater than m. So when h equals 1, this one miserably fails actually, and only this one passes, basically 2 passes. So minimum hits we need to consider. Means in the question, when I say minimum hits in the question, they have asked, what they have asked, basically we have to find the minimum number of attacks that is required to defeat at least k enemies, at least k enemies, right? So we are going with killing all the three enemies, right? K we have been given 3. So somewhere here in the question itself they have given k equals 3, m equals 5. We are just going with this input, and n equals 5. So m here is 5, k here equals 3. So we have to kill three enemies in two shots, right? So it is possible, two attacks, sorry. H equals 2 we are considering, right? H equals 1 miserably fails because 7 is greater than or less, greater than or equal to, greater than m. Here m is 5, here we know greater than m. Here we got, when we performed the calculations, we got the 4 is less than or equal to 5. Yes, so it was possible. Further we calculated the things accordingly, and yes, 4 is less, I mean, yes, it is possible to kill all the enemies, means kill three enemies, right? So here h equals 2 is possible. In this case h equals 2 is possible, right? Just give me a second here. H equals 2 is possible. So here in this case, final binary search, the output that we got is 2. Nothing but, so minimum hits equals 2 here. Minimum hits equals 2, right? So the output that we got here is 2, which is equivalent to the output that they have mentioned for x, that they have mentioned for this one, for the first output, for the first example within the question, right? So the output that we got here is 2, which is equivalent to the output that they have given for the first example within the question, right? So our approach works absolutely correct, and the binary search approach basically works absolutely correct. So this exactly we have to articulate the same thing in the form of code. Exactly whatever we discussed, we have to articulate the exact same thing in the form of code. This is the best intuitive approach that I have found basically for this particular problem. So we will be articulating the exact same thing in the form of code, right? So I hope the approach part is completely clear. I hope the approach part is completely clear. Now let's quickly discuss the complexities. Now let's quickly discuss the complexities before writing the code. Here, just give me a second. So here the time complexity would be logarithmic n into logarithmic max h, right? N into logarithmic max h per individual test case. So here what is max h? We are considering the max h right here. So what will be the max h basically? Max h is nothing but the this one constant 10 to the power of 9 or 1e9 here. 1e9. So this is the binary search range. 1e9 is the binary search range, right? So that they have given in the, what do we call, that they have given in the um, constraints basically for this particular problem, right? So max h is nothing but 1e9, which is in the binary search range, and n is nothing but the number of enemies. So and n, this one I'm speaking, n is nothing but the number of enemies, right? So again I'm telling, you could have this one, you might have some question with this one logarithmic max h. So n is nothing but the number of enemies, we know that one, right? According to with the problem. So logarithmic mx m max of h is nothing but, here in this case again I'm telling, uh, it is the binary search range, right? It is the binary search range. So log of this one 1e9 is nothing nearly equal to 30, basically 30, right? Total which is acceptable within this one, less than or equal to 1e5, basically they have given 1e5, nothing but this one 1e5. So overall time complexity would be quite obviously big of n into logarithmic max h. And what would be the space complexity here? The space complexity would be big of n. Why the space complexity is big of n here? Because we are going with the extra space for left and right. So this we will see when we are performing the binary search, right? So we will be going with the extra space for left and right, and we'll also be making use of the temporary arrays for the test case. Right. So we'll be making use of the temporary arrays for test case as well. So in the for the worst case, it would be the space complexity would be big O of n. Right. So the time complexity would be big O of n into logarithmic max h, and the space complexity would be big O of n for the code that we'll be writing in the future. Now we are completely familiar with the approach as well as the complexities. We are good to write the code. Let's start writing the code. Now let's start writing the code, right? So let me come to the compiler here. So here, first step, we have to go with the, I mean, we'll be making use of the fast reader and print writer, or the fast output, fast input and fast output basically. So for that one, let's import here input output. So I'll just go with Java input output dot star. So next we'll be making use of the utility. Let's go with the utility package here, utilities, right? So I'll just go with util dot star. So this is fine. So next let's go with class. So public class, I'll just name this main. You can just give any name, so I'll just give main here. So we are going with the fast reader as well as the fast this one writer, nothing but here in this case let me make use of static fast. So just give me a second here. So let me go with static fast. reader. Here I'll just consider this one SC scanner. So basically new fast reader. This is fine. For the fast writer or the for the fast writer, let's go with the print writer. So I'll just go with for the fast output, right? So here I'll just go with print writer. Fast output writer will be going with the print writer. So I'll just go with the out. This represents the output, right? So I'll just go with a new print writer. So this one, let me pass system dot in here. Sorry, system dot out, right? So we're just going with the output. So this is fine. So just give me a second. What is happening here? Yeah, let me give main here. So let me delete this one. Let's make use of throws input output exception as well. So here in this case, throws output exception. This is fine. So within this class, first what we'll do, so we have to read the number of test cases. We have to read the number of test cases. In this case, I'll just go with t equals sc dot next. So let's make use of the next int here. So because we have to read the number of test cases, right? So here in this case, next int. This is fine. So next. So here let's move on with the further steps here. It has to be greater than 0. Then what we'll do, first we need to read the number of enemies, also the attack power, and attack power is nothing but n, m, and k inputs, right? N, m, and k, what they have mentioned. So n is nothing but the number of enemies, attack is nothing but the attack power, and k is nothing but the number of enemies that we need to defeat. In the first example we had, if you remember, n equals 5, m equals 5, and k equals 3. N and m are we had n and m number of enemies, and the attack power was 5, and enemies to defeat we had 3, right? So h equals 2 we considered number of attacks that we can perform. We guessed, we just went with a guess, right? So we went with initially one miserably failed, so we went with two was possible. So minimum number of attacks that was required for 2, that was required for the first input was basically 2. Right, so here in this case we are articulating the same thing in the form of code. We are just in the form this one still in the initialization, but here we let's initialize the number of enemies. Here this one, n equals sc dot next int. Here same thing, let me copy this one and make the necessary changes quickly. So here let me go with this one again. uh yeah, so let me make this one m, and let me make this one k, right? So this remains same, this is fine. Next we have to go with the enemy health and enemy position as well. So enemy health, I'll just consider, for the enemy health I'll consider the variable h. So this will be new int of n, n, right? N itself we have to pass n basically. Yeah, for the enemy positions, so I'll just go with here x equals new int of, again this will be n again. So this is fine. So let me come out of this one entirely. So we have to input the health and we have to input the position. So for this one we'll be making use of two for loops here. Let's write the code, or let's articulate this one very quickly. So I'll just go with I equals 0. So we are inputting health first, so this will be I less than n. So for inputting positions also we have to consider n itself, right? So here in this case this is fine. H of I equals sc dot next int. So this is fine. So this will be again for int I equals 0. I would have copied, man. I would have copied and made the necessary changes. So here I didn't give n at all. Why? What happened? This is fine. Let's increment the I. Here this will be instead of this one. What we are not inputting health this time. We are going with the, I mean we are inputting the position. This will be x of I equals same thing, xc dot sa dot next int. So this itself I should have done. This itself I should have. I mean I should have copied and made the necessary changes. This is fine. So one thing here, we have to perform the binary search for minimum hits. We have to perform the binary search for the minimum hits. Still, we haven't written the this one, what do we call, binary search function. So let's make use of this one later. Let's come to this part later. Means we have to binary search for minimum hits. We are going with the binary search for minimum hits accordingly with the approach, if you remember, right? So we are going with the binary search for minimum hits. So yet we have not written the binary search function yet. We will write the binary search function, then we will make use of it here. Let's come to this part later. So we have to flush the output. Let me give here out.flush, out.flush. So line number 19 is blank for now. Will come here once we write the binary search function. So now let's perform the binary search on number of hits. Let's do that, right? Let's perform the binary search on number of hits. So let me go with static int. I'll just go with the binary search. The parameters I need to consider here is I need low. I'll just give LO, and I need high. I'll just go with HI. I need this one H X M and K. This one H number of hits, X this one we need X M and K, right? H X M K, int X, int H, int M, int K. So this needs to be represented in the array. So this one has to be, so here we need to give array, sorry, this one also array, and this one also array. This is fine. So within this we are performing the binary search on number of hits, right? So here first what we will do, let's initialize answer to -1. So in the output they have given, if it is not possible, so sorry, not in the output, in the question, I got confused, sorry. uh, Here, while reading the question, I said one thing, we have to find the number of attacks that is required to defeat at least k enemies that they have given in the input. If it is not possible to defeat the enemies, then we have to return -1. Means if it is impossible, then we have to return -1 in that case. So let's go with answer equals -1. Let's initialize answer or the result. So I'll just consider ANS here, answer. So let's go with the pure binary search here. So I'll just go with while low less than or equal to high, then what we'll do, let's calculate the mid first. So this will be in mid equals low plus this one will be high minus low by 2. This is fine. We are just going with the current hits to try. So first we went with 2, first we went with 1, first, then we went with 2. We are just taking the guess, right? So we are going with the current hits that we need to try here. So we are going with the this one. We are just calculating the mid, or we are just going with the current hits that we are going to try, basically here, this part. So here, if it is possible, so if it is possible means, can we defeat the greater than or equal to k enemies? Can we defeat greater than or equal to k enemies? So with the power, so h was 1 initially. It was not possible. It was not possible. The value that we got was 7, if you remember. So which was greater than m. The value should be less than or equal to m, right? When h equals 2, attack power. So when attack power h equals 2, number of attacks, basically number of attacks. This one you can just say not attack power, basically number of attacks. So when h equals 2, it was possible because we got the value 4, which was less than or equal to 5, nothing but m. I'm speaking of the example one that we considered in the approach, right? So here, that itself we have to find whether it is possible or not, means whether we can defeat greater than or equal to k enemies or not. Let's do one thing before carrying on with this one. Before carrying on with this one, let's do one thing. uh, hmm, let's write the helper function is possible, if it is possible to defeat greater than k enemies or not. Let's do that one. Let's make use of the helper function for that, and then let's make use of it on the binary search function, right? Let's make use of it on binary search function. So here I'll just go with, so static boolean is possible. This one here, I need the parameters h x. So hits also int m, and here int k. This is fine. So within this function is possible function, we'll be making use of the length of the h many times. So let me assign this one to the some variable. So here I'll just go with n equals h dot length. This is fine. So the next part is here we have to go with the interval start and we have to go with the interval end. Means so we tried with the three intervals as k was 3, if you remember, right? When we tried the value of p equals 2, 3, 4 within the three intervals, if you remember the approach, that's what we need to articulate in the form of code, whether we are checking whether it is possible or not, right? So we are checking if we can defeat at least k enemies with the given hits. So first we considered 1, it was not possible. When we considered 2, it was possible. We are just checking if we can defeat at least k enemies with an given hits. So let's go with the interval start, nothing but where an enemy can be killed, and interval end, right? So here interval start, I'll just consider left, right? So during the space complexity, I said we'll be making use of the variable left and right. So uh, right, so the overall space complexity would be big of n. So here this is the variable I was speaking of. So here this would be new int of n. This is fine, new int of n, nothing but the interval start, and this is nothing but the right int right. So here this would be new int of n. This is fine. I hope this is clear. This is nothing but the interval end. So this is exclusive, right? So this is basically exclusive. This is fine. So now we have to go with the size of valid intervals as well. So I'll just go with size, or let me give sz for the size. This one, let me initialize this one to 0. So this is fine. So let's carry on with the, or let's move on with the iteration part. So I'll just go with int I equals 0, I less than n, and I plus plus. So this is fine. So within the for loop, first what we'll do, we have to go with the hits that is required to kill the enemy I. So I'll just go with the variable need here in this case. This will be h of I plus hits minus, sorry, not equals, minus 1. So we are just going with the hits that is required to kill the enemy I, right? So minus 1 by hits I didn't give, sorry, I forgot. I think this is fine. Next, after going with the hits that is required to kill the enemy I, so what if we cannot kill the enemy within the given range? Then we have to skip that part, right? To skip that part, we will go with the continue keyword, and let's write the simple if condition before that. So if need is greater than m, in the first case, if you remember the value, nothing but the need we got is 7. 7 was greater than m. In that case we skipped, and then we tried with the h equals 2. I showed first, I said this one in the approach as well. First I had to show when h equals 1, number of attacks we had was, first we were trying with 1 and then we were trying with 2. So I showed when h equals 2 first, because it was possible, it was possible to kill all the enemies with the 2, means with number of attacks given 2. So here when h equals 1, it failed miserably, right? So at that part when h equals 1, we skip that one, and we have to try for when h equals 2, right? So here when need is greater than m, we will go with the continue keyword, right? Simple, very simple. So here next thing is, let's go with the extra distance that we can afford, nothing but m minus need. M minus need, here I'll just go with the keyword spare. This one equals m minus need. This is fine. We are just going with the extra distance that we can afford. And now let's go with the left boundary of the p and the right boundary of the p. So I'll just go with here int L equals, this is nothing but the left boundary of p, x minus I minus spare. and let me copy the same thing here and make the necessary changes for right boundary of p. So here let me paste it over here. Let me change this one to right. So x of I plus pair remains same here. So this one has to be plus for the right boundary of p. So this is fine, I think. So here let's go with left of size. Let's initialize this one to L, and let's do one thing here. For the right, we have to go with left comma right plus one. Nothing but this is inclusive, right? So here in this case, right of size equals R plus 1. This is fine. L comma R plus 1. This is inclusive. So we have to increment the size here. In this case, we have to increment the size here, right? So let's do one thing here. Mm, Next step is we have to sort all the intervals. We have to sort all the intervals. Before doing that, can we make use of this one? Is possible. We are not done with the this one, I think, right? So let's do one thing. First, let's carry on with this one, basically. So what shall we do next here? Let's sort all the intervals. So in the ascending order. So I'll just go with the arrays dot sort. Left and right we have to uh, consider, right? So this will be left comma 0 comma size, and same thing arrays dot sort here. Instead of left, I'll just go with a right comma 0 comma size. We have considered sz. So this is fine. So the next part is let's go with the let's consider active intervals. Here in this case, let me go with max equals 0 comma count equals 0. This is fine. Max equals 0, count equals 0. Let's consider I equals 0 comma j equals 0 as well. So here let's go with a simple while loop. I'll just give while I less than sz and j less than sz as well. So within the while loop, what we will do, let's go with a simple if condition here. If left of I, if iterated value of the left is less than right of I here, right of j, sorry, I and j we considered, right? Less than right of j, then what we will do, within the if condition, we have to go with a basically new interval start. So here we have to increment the count, and also we have to increment the I hope this part is completely clear. Easy, right? So let's go with the next part. Nothing but in else, if we have the same point, then we have to move both. So here in this case, I'll just go with else if left of I, if we have the same point, means comparing right of j here. So sorry, right of j. Then what we need to do, we have to move both. Nothing but I plus plus and also j plus plus. This is fine. If we are at the same point, then we have to move both. Let's go with the final condition here. Else, what we need to do, we have else we have to go with the interval end or interval ends here. Means we have to decrement the count here, and also we have to increment the j. So here nothing but we are ending the interval, ending part of the interval basically, right? So this is fine. So next, what shall we do? We have to track the max overlaps. So here in this case, max equals math dot max of. So this one will be max comma count. Max comma count. We are just tracking the maximum overlaps. We are just tracking the maximum overlaps. So here we have to check if at least k enemies can be killed. Means at least in our example k was 3. It was possible within the two attacks. It was possible to kill all the this one all the enemies, means all k enemies with number of attacks that we considered was 2 basically. With 2 attacks we could kill all the enemies, right? So here in this case, we have to check if at least k enemies can be killed. So how can I write that one in the form of code here? So I'll just give return max greater than or equal to k. Max greater than or equal to k. So this is fine. This is fine. I think this is fine, right? Let's do one thing here. Let me come out of this one. So now we are done with the this one is possible. We are done with the is possible. The same thing, we'll be making use of the is possible function within the binary search function, as I've said. Before that one, let me do one thing. We have the this one. What do you call? We are making use of the fast reader here. We have. Let's implement the fast reader. I'll just copy paste that one. I'll just copy paste that one because it's not related to the logical part. It's just related to the input output. You can just pause the video and have a look into it. Just give me a second here. So here, let me do one thing. Let me copy paste here. This is fine. I hope this part is clear, right? So just give me a second. Somewhere I missed something, man. I don't know what I missed. I missed miserably here. I don't know what I missed. So just give me a second here. So yeah, let's do one thing. Let's remove this two brackets. So this is not necessary. So these two brackets here, we already have this one. So here you can just have a look into it. So from here to here, basically, this is nothing but the this one. What do you call? Fast reader implementation. Just for reading the inputs, we have to read the input, right? We have to read the inputs, right? So the inputs that were given, m equals 5, n equals, we have to read the inputs. We have to go, we have imported basically input output package for that. So we are just implementing the fast reader, right? So you can just pause the video and have a look into it if you want to use the same this one template, right? So here, yeah, this stops here. So this is it for the fast reader. This one, what do we call? Implementation. Now we are done with the is possible function, right? Let's do one thing. Let's carry on with the this one. Move on with the binary search function. So here we left. Basically, we calculated mid and left. We wanted this one is possible function. So where were we basically? We were checking whether we can defeat the greater than or equal to k enemies or not. So here if so I'll just go with is possible. I'll just make use of is possible here. What are the parameters that we need to pass? H, X, mid, this one M as well as K. M as well as K. So within this if condition, so possible answer can be mid as well. So let's initialize to mid first, right? Then we have to try fewer hits as well. So we have to try fewer hits. So we tried with initially one, it miserably failed. Then we tried with two, h equals two. Then it was in our case, it was possible. We could kill all the enemies, right? So that's what we are doing. Let's try with the fewer hits first. So this will be high equals mid minus one. This is fine. So else else what we will do here, we need more hits. We need more hits means here it will be low equals mid plus 1. Low equals mid plus 1 if we need more hits. Basically if one was not possible in our case, so we went with the next one, right? If we need more hits, then we'll go with low equals mid plus 1. Then we have to finally return the result. So I'll just go with return. I have considered the variable answer here, this one. So here, if it is not possible, we'll be going with, if it is impossible to kill all the enemies, then we'll go with minus one or we'll return the answer here. This is fine. So we are done with the binary search function. As I've said, we will be making use of the binary search function within the main here, right? So why we need to make use of the binary search here? Because we have input the health and position here, this one line number 17 and 18. After inputting the health and positions, we have to perform the binary search for the minimum hits. We have to perform the binary search for the minimum hits, nothing but in our case in the constraints they have given 10 to the power of 9 or 1e9, right? So here I'll just make use of out dot println. This would be, I'll just pass the binary search here, binary search of let's pass the parameters. Let's pass 1 here. So we have the constraint 1e9, right? So here 1 followed by 9 zeros here. Just give me a second. Why this is not getting typed here? So this is fine. 1 followed by 9 zeros. 3. This is fine. And we have to pass the parameters h, x, m, and finally k. So we are done with the code. So we are done with the coding part. So we are performing the binary search for minimum hits here. We have already written the code for binary search. We are making use of it within the main function. So this is fine. So finally we have made use of the out flush. So here we are flushing the output. This is fine as well. Right. So we are done with the coding part. Basically, again, I want to tell you. So we have we are performing the binary search for the minimum hits. To perform the binary search for the minimum hits, we have separately written the binary search function. So I have to leave space here. So this is fine. We have separately written the binary search function, and we have made use of the binary search function, right? So here, right? So here, because we have considered this parameter, because the constraints, so we have is 10 to the power of 9, 1e9 basically, right? So I hope this part is clear. And to perform the within the binary search, we have to check whether this is possible or not. When I say whether this is possible or not, means can we defeat greater than or equal to k enemies or not. Here in this case, yes, uh, means we have to check whether it is possible or not, whether we can defeat greater than or equal to k enemies or not. For that one, we have written is possible, whether we have written is possible function here, right? We have written is possible function here, right? Then we are going with a sorting here, same within the same is possible here, is possible function. So I hope this part is completely clear. Simple thing is we are performing binary search, and we are checking whether it is possible or whether we can defeat the enemies or not, k enemies or not. For that one, we are making use of the is possible function. Main thing is here, one main function. Within the main function, we are going with the binary search. We are performing the binary search on the minimum hits. So we have written the binary search function. Within the binary search function, we are checking whether we can defeat the k enemies or not accordingly with the input. So for that one, we have written separate function. These are only the three things that we need to check here. These are the only three things that we need to check here basically. So we have discussed the approach, exact thing whatever we discussed in the approach, we have articulated in the form of code, to be frank, right? So exact thing whatever we discussed, the calculation part, so we articulated the exact thing in the form of code here, right? I hope this part is completely clear. I hope this part is completely clear. Simple thing, we are performing the binary search on minimum hit, so we have written the separate function for the binary search, and after within the binary search, we have to check whether we can defeat k enemies or not. So for that one, we have written is possible function here in this case. And this one, again I'm telling, this one you can have a look into it. You can just pause the video and have a look into it. This is nothing but the, this is not the logical part, this is nothing but the input output. So this is just the template part, so I didn't type this one, right? You can just pause the video and have a look into it, this part, right? So we are making use of the fast reader here, fast reader and fast this one, what fast input and fast output. For the fast input, we are making use of the fast reader, and for the fast output, we are making use of the print writer, right? So the fast reader, here we are implementing the fast reader here. We are implementing the fast reader, nothing but the fast input, right? So I hope this part is completely clear. So this is it for the code. So let's check whether this works or not with the inputs they have given. So here in this case, let me copy. What is the output that we need to get? Double two minus one. So here last two numbers I'll consider 971500. So let's check whether this works or not. I hope this works, man. So we have some error here. Java.io.8 I have given line number one. So yes, this has to be star. So let me run this one again. So now we have the error in the line number 66, empty character literal. So where I have given literal character literal, line number 66. So here, so yeah, this I would have mistyped this one. This is fine. Let me run this one again. So this error is also gone. Here now we have the error on this one. Hmm, what we are doing? Why I have given else if within the else here? So just give me a second here. We are incrementing the I here, I plus plus. So this is fine. Else part is next actually. Why I have given this one here? Don't understand, man. Sometimes I really don't understand. So this is fine. Now this is fine. Now this is fine. Um, Let me hit the run button here. What happened? Method binary search in class main applied to given types. Binary search, this one required int in, this one array, this one, yeah, this is fine. So what happened here? Didn't I write this one here? Yeah, low high, this one x array, That's what we have given here, right? Int and this one, yeah, found int and so here we have mentioned the array, right? Int m, int k. What is wrong here? What is wrong here? So let's check what is wrong here. Oh, line number 25, we have error, cannot find the symbol. Let I have given where? So this one has to be int my JavaScript. Uh, cannot find the symbol high. Oh, this one has to be hi. That's it. I have typed completely high. Line number 26. So let's clear one by one very quickly. So this is fine. So here line number 28. Before this one, in line number 17, we have done something wrong. Uh, line number 17 or some line number 19, right? So before this one, let's do one thing. Let's check other errors. We are done with most of the errors. So the last one here, error method is possible in class main cannot be required intent. So here in line number 28 is possible. Uh, what is wrong here? We can, right? So just give me a second here. So yeah, if it's possible of the parameters that we passed here is hx mid mk. This is fine. What is wrong? So let's check what is wrong. So what mistake I have done here is in the line number 910, class main cannot be applied to the given types they have given. Here this has to be in h. This h has to come first here and then x. So now this error has to go. Let's see. Still we have this. Let's check this one first. Line number 28 here. Method is possible in class, main cannot be possible. So here we have to pass. I think, yeah, I have done mistake here. So this has to be hits, right? So we are making use of the hits. So this has to be hits, not this one. What do we call h basically? So this is fine. So let me try to run this one. So again we have two error here. What error we have? Error cannot find symbol h. So here we have passed h, right? So hx hits mk we are going with. So where is this one? Int h we are going here with int hx, right? Hits m and k. So this is fine. Why this is not considering h? Cannot find the symbol h. Oh, so yeah, here no, not this one. Where is binary search here? So yeah, here this has to be h basically. Here it has to be hits. This is fine. Yeah, low high hxmk. This is fine. So now let me run this one. Now we have two more errors here. So one mistake I have done here in the binary search. So here we don't need the array basically. M and K we are going with, right? So we don't need array for this one. So we just need array for the X, H as well as H and X. That's more than enough basically. So here low and high we don't need. For H and X we need the array that we need to represent, and M and K doesn't need. So let me run this one now. I hope the error is gone. Yeah, now we are getting the output 2 2 minus 1 here, 2 double 2 minus 1 971500 971500. We are getting the correct output, right? So this was the mistake basically. I have so in the binary search and this one parameters basically, so I didn't mention hits here. Instead of hits I had mentioned h, and here on this part, so we had to remove the array basically. Array was not required here, right? So this was the main mistakes, and there were some typos that we corrected that were easy basically, right? So this is fine. So this is it for the code. So this works absolutely correct, right? Code works absolutely correct. So let me do one thing. Let me paste the signature template here. Let me paste the signature starter template. So this is fine. So I hope this works for all the test cases. Let's see. Let's do one thing. Let me copy this one entirely. Let me paste this over here and let me hit the submit button. F, right? Problem F. Yeah. Ardent flames. So I hope this works for all the test cases. Let's see. It has to. Only three steps again. So in the main function, we are performing the binary search on this one, the number of hits basically, minimum hits. And to perform that minimum hits, we have to check within the binary search. We have to check whether this one can we defeat the number of enemies or not. Means k. Can we defeat greater than or equal to k enemies, right? So that's what we need to check. For that one, we wrote one more helper function, nothing but is possible, right? And we had that one as well, fast reader is nothing but the fast reader implementation, right? Fast reader, fast input in this one implementation, this part, this part, right? Yeah, this one is nothing but the fast input part. So this is it for the code basically. Let's see what is happening. Yeah, you can clearly see here the code got accepted, right? So the code got accepted here means the whatever the code that we wrote works absolutely correct in this case. Right now we don't have to discuss this one again. So we have discussed the approach multiple times and we are done with the code as well, right? Coding part as well. So now I hope the solution part is completely clear along with the approach and complexities part, right? For now, this is it. Thanks for watching, guys.